Hello again, everybody. I'm Chris. Today I'm going to be analyzing some data that's mock data that I generated. For an imaginary business, I have transactions and I have revenue and cost. You can see those here, and we have hundreds of thousands of transactions over the course of a year, and I am going to analyze all of these. I don't think I could even find the end of it. It's somewhere near here. Yeah, I'm not going to be able to find the end of it. There are just flat out too many. But what we are going to do is take a look at this project, and I'm going to demonstrate what is possible through data analytics. All right, as you can see here, I have imported my CSV file into a data frame, and now I can take a look at kind of what I've got. It's pretty straightforward. The transaction number is probably not going to be useful to me, but I'm going to have the dates. I can also take a look. We want to make sure that it's uniform across the board so we can see all the way to December 31st of 2024. We have 196,541 transactions or data points, all with the transaction number, revenue, and cost. So we are going to analyze this data and look at things like operating margin across a few different time periods. So one thing I'm looking at here, I'm looking at kind of a breakdown of the statistics of this. I can see that there are 196,542 data points or rows in the date column. That matches up with rows in the transactions column. So we don't have things mismatched. We would get errors if that happened anyway. This stuff here is not exactly useful. It's not exactly useful. I mean, we could look at that and say 50% of the transactions happened before, July the 1st, but that's obvious when we look at a calendar and go over that. That's not really going to tell us much. The revenue, we can see that the average revenue from any single transaction was $100.50. The minimum was nothing, and the cost was 44 cents on that. I'm not really sure how that would happen, but it can happen. Who knows? Maybe it was a ketchup packet or something. We have to use our imagination because it's mock data. I'm sure that can happen somewhere. If it said all nines for either of those, I'd be worried about it. Or if it said all threes or something, I'm not too worried about that. The maximum was 302. The maximum cost accrued on any single transaction was 102.2. So this all looks fairly normal. I can agree with this. None of this is really striking or standing out in any particular way. Standard deviation of revenues, $44.06, 7 cents, whatever. Standard deviation of costs, $12.49 or $12.50. That means this imaginary business is probably performing somewhat well. However, we are not taking into consideration fixed costs. So I have coded some visualizations here. I've got the distribution of revenue across the transactions with some vertical lines showing the mean and the median values. There are definitely some outliers here. We can see that there's this tail. It's not terrible. I don't think this is really throwing everything off too bad, but there are definitely outliers. It looks like our mean and median are close. They're within 40 cents of each other. I also did a box plot. This gives us another look at it, and these are our outliers there. These will either need to be filtered out or not. I haven't made up my mind yet. I'm going to do some of the math and stuff to decide what needs to happen there. But the mean and median are pretty tight. So these outliers may not be skewing things off that bad. We could be right in the ballpark with or without them. I don't think they're doing any terrible damage. We can see here how much it's skewing them, and barely a little bit. But for good practice, I'll probably remove them, see how bad it messes with these numbers. If it doesn't change them very much, then it doesn't matter. But if I see that these numbers change, then the outliers will be out. I'll continue with a filtered data set. So I went ahead and did some visualization for the cost as well. This is even tighter. This looks pretty good. There's outliers both directions. We know what's coming. When I go to the box plot, that is exactly what we're looking at here. We've got 1 penny a difference, but we have outliers below and above. And I've been toying with it a little bit. I'll show you what I've been working on in just a second. Here is the next visualization of net income. So this is going to be revenue minus cost on each transaction. We can still see that there's outliers. So we saw that coming as well. They're still below and they're still above. So when we get into the next step, I would normally do is I'd go into contribution margin. But what we run into with that is we have situations where revenue equals 0, which means we're going to try and divide our net, which is a negative number, by 0. And when you divide by 0, computers do all kinds of cool stuff. That's just loads of fun to try and figure out. So we're not going to do that. What I'm going to do is I'm going to aggregate revenue and cost by the day, which means net will be aggregated by the day. And then we can do the margin based on those numbers. So what I've done here is I've added some helper columns. I've added day of year. So January 1st, every single time is going to have a value of 1 all the way up to 365 or whatever. The name of each day, if I decide to use that, it's there. That way we could do like week over week or Monday. We could look for seasonality, do Tuesdays suck and Saturdays are awesome. That's what this column's for if I decide to do that. The name of each month, that way I can aggregate by the month. So, and the number for each quarter of the year, so I can aggregate that way. So I could do daily performance, day of week performance, monthly and quarterly performance. And this data is from January 1st of 2024 to December 31st of 2024. So doing it annually doesn't make any sense. Now here we can see a visualization of the distribution of margins. So this is daily performance, what we're really looking at. The spread between mean and median's not great, but it is skewed a bit, and we can see that. But this makes a lot more sense. And to be honest, I would say right now, just looking at this is a business that looks sustainable. Now we're not taking direct costs into account, but it does look sustainable. And we can see here, we do this tail right here. We do have these outliers, but there aren't many across all of these days. We've only got, however many that is, they could be stacked on top of each other, but it's not nearly as bad as what we had up here a moment ago, where we were seeing this dark, bold line right there. What we have makes a lot more sense. It's more cleaned up. This is a little better. And I'm going to continue to aggregate this and measure the performance across different time periods. And here we can see monthly aggregate distribution. It's just the same thing, contribution margin. It's over 12 months. Same thing here. We're seeing less outliers. This is common when you go from daily data into monthly data. It clears up a lot of noise. It starts to smooth everything out. I expected this. It's one of the reasons why I planned on doing it. This is starting to look a lot better. I'm going to go ahead and do quarterly just to look at it. A histogram with 4 bars probably won't tell us too much super useful information. Probably what would be better would be just a regular bar chart. But I'm going to go ahead and do it, and we'll take a look at that next. And here is the distribution by quarter. So this is a little bit informative, but there's significantly less data points. Now I'm seeing that there's only 3 bins, so one of the quarters must not have performed extraordinarily well. That's okay. We can still see this. Everything's still nice and tight. I've got the box plot here as well. That's what we need. And the next thing I'm going to be doing is actually going to be data visualization for the user. Histograms and box plots are useful for me, but the user needs something actionable, something that makes a whole lot more sense, something that they're more used to seeing and reading. So I'm going to do some plots, some trend lines, a few line graphs to show how things are moving along, and I'm going to explain what happens. Now let's look at a trend over time for a cumulative margin. Basically, I've done performance margin. This is your contribution margin as you accumulate costs and revenue over time. Now, what happens with any business is in the early days at the beginning of the period, because we're starting at 0 or 1, we're seeing a lot of noise. This is because we have some items that will have good margins and some that will not have good margins. As you accumulate, your margin can jump around, your contribution margin, I mean. And as you accumulate, it will also average out. Hopefully what happens is it goes up and averages out up here. Sometimes it'll average out in the middle, and sometimes it'll drop and average out way down low. All of this noise looks horrid and awful, but it's between 50% margin and roughly 50% margin dipping down here. So it's really not that noisy if we zoom out. It basically just looks like a line. Now, if we go from daily to monthly, we see that it's not nearly as noisy. Now we're looking at 12 months time and we see a trend. We're basically going down, and it tries to pull back up, but we're going down. Month 5, May, that's our lowest point. Keep in mind, by the way, we're still 50% margin, 50% margin. It's not like we're dying here. So we're looking at this very stable when we zoom out. When we zoom in like this, we get some granularity. We can go to quarterly, and now we see that we're still on the same scale, but we can see that the third quarter of the year was the low point, and the first quarter of the year was actually the high point. So now we're able to look at some trends of this margin. And basically what this margin means is this imaginary business is making about, or they're keeping about 50 cents of every dollar they make, and they can use that money towards fixed costs. So that's what we're analyzing here. Here is a visualization of cumulative revenue versus net profit. This is also monthly, so this is each month of the year. Now we can see how much of the total profit was net, and we see that it's in that 50% range each time. There's not a lot of volatility going on here. And here is our visual for quarterly. Again, margins right across the board in the middle. Very, very stable. Mock data is like that. So now we're on to non-cumulative revenues. This is just each day of the year. This is super noisy, as you can see. Even a 9-period moving average, it's just a flat line. This right here doesn't tell us anything. There's not really much sense in wasting time on this. If we move on to look at monthly, we'll see that there's 12 periods here. A 3-period moving average didn't contribute a whole lot. It did smooth it out and give us an idea of the overall direction that we're headed here. And then quarterly, there's no reason to have a moving average. It's very simple. Looks like we're on an upward trajectory as far as the quarters go. Now, in this case, what I would pay most attention to doing this analysis, if this were real, is these things are all straight across the board. That's not anything to worry about. I would say this is about as rock solid as it could be if this were real, I guess. What I would look at is actually up here, the cumulative margins. This is what I would pay attention to, because this is where optimization can happen. If you calculate the contribution margin of each one of your products, the ones with the greatest contribution margin are the ones that raise this line from here up here somewhere. And that's what we want. We want to optimize margins. That means packaging certain things together intentionally, rather than just picking 3 or 4 random items or 3 or 4 random foods to make a meal. Consciously select things and put something together that boosts margins. And you don't want to do it here when it's already averaged out, because it would take a lot to bring this back up. You want to do it at the beginning of the period. Right at the very start, when it's very volatile, we want to optimize then to get the margin as high as possible and keep it there. Ultimately, we cannot control Mother Nature, and people are going to buy things that they can afford. That's what will happen. But the more that we can optimize, the higher this can be. And then once it's averaged out a little bit, one bad day doesn't create this huge drop right here. Once it's averaged out, we can take that drop. But that's where I would say to focus on the daily side. As far as cumulative margin monthly, the same thing is here. We want to try and optimize as much of this as possible, because if contribution margin dips, then we have less money to contribute to fixed costs. And fixed costs are the things that can put you out of business, of course. Same goes for this, for the quarterly margins. Now, the range of this at 50%, basically every value is 0.5 with a bunch more decimal places after that. This is extremely stable, and that's what we see right here. This is extremely stable because this is mock data, but in a real scenario where that variance were higher, if the margin looked like this, we might start to dig a little deeper. But I hope you've enjoyed watching along this demonstration. This has been a basic business performance analysis.